Welcome to aminacademy.com. In advanced calculus, let us discuss about sequences. A sequence is a list of numbers or elements that exhibits a particular pattern. Each element in the sequence is called a term. A sequence can be finite, meaning that is it has specific number of terms, or infinite. That means it continues infinitely. Sequence can be described in different ways, such as an explicit formula, a recurrence relations, and table of values. Like now, for example, consider the pattern of the numbers. Suppose un equal 3, 8, 13, 18. What you notice this number pattern? Look at here. This first is 3, second is 8, means what's the difference? 5 difference. 8 and 13, 5 difference, and 13 and 18, 5 difference. In this pattern, so we can continue this sequence by using nth term. For this, suppose the first term is 3. Now nth term we can say un is first term plus the common difference 8 minus n minus 1. The common difference is 8 minus 3 is 5, which means 3 plus 5n minus 5. Therefore, un can be written 5n minus 2. That means the nth term we found. By using this formula, we can find any number of terms here. Suppose if you use n is 10, that is 10 into 5 is 50, 50 minus 8 is 48. What do you mean? The 10th term must be 48. Like any number of terms you can find in that. One more pattern, look at here. Un equal to 1 by 3, 1 by 5, 1 by 7, 1 by 9. Here, what is nth term here? Un 1 over 3. Look at here, 3, 5, and 7. That is difference is 2. That is 3 plus n minus 1. Difference is 2, which is equal 1 over 3 plus 2n minus 2, which is further equal 1 over 2n minus 1. So like this, we can find nth term. Now, in further discussion, we can do some examples. Before that, theorems on limit of a sequence. Here, by using limits, we can explain the sequence. Look at here, let limit n tends infinity, that is an equal to a. We let limit an, that is sequence an, which tends n tends infinity equal to a, like limit bn n tends infinity b. We give two pattern here. Means first one is an, sequence an, second one is bn, so we let capital A and B. From that we can find theorems on sequence. First one, limit n tends infinity, an plus bn is, suppose addition of two sequence is equal to separately limit an, which n tends infinity, plus limit bn n tends infinity, which is equal to a plus b. Similarly, a minus b we can express. Third one, limit n tends infinity an into bn, that is two sequence is multiplied, which gives limit an n tends infinity into limit bn n tends infinity, which is equal to a into b. Like division, limit an n tends infinity divided by bn, which is equal to limit n tends infinity an over limit n tends infinity bn equal a over b if limit bn n tends infinity equal to b not equal to 0. If b should not be equal to 0 for this expression, if b equals 0, what happens? If b equals 0 and a is not equal to 0, then we can say limit n tends infinity an over bn does not exist. That means if a equal to 0, the first limit is 0, then the limit does not exist. You can decide. If b equals 0 and a also 0, that is both a and b 0 here, then you can say limit n tends infinity an over bn may or may not exist. Here, if a is not equal to 0 means, of course, you can say does not exist. If b equals 0 and a also 0, then you can say may or may not exist this limit. Then power. Limit an power p n tends infinity, then we can say which is equal to limit an n tends infinity whole power p, which is equal to a power p for p any real number if a power p exists. Next one, limit p power an, that is any number p power that sequence, which is equal to p of power an limit an n tends infinity, which is equal p power a for p any real number if p power a exists. These are the rules of limits, that is theorems on limit of a sequence. Now let us do some example problem regarding these limits. Now, so far we discussed simply about what is sequence, what is the theorems on sequence. We have done. Please subscribe our YouTube channel.